Okay, so we are recording now. So the material 1, steel, for example, 2.1 E5, because we are in millimeters here, yeah, 0.3.
For the material, did you select the?
Yes, I'm listening. I just I
the same.
I will finish this one, yeah, and then I can go back, yeah.
Okay.
Stress, for example, 300.
The same value.
Yeah,
Okay.
so
Okay. Yes.
yeah, material. So it's a general steel, yeah, and it's just a very general steel. General steel. It's used nothing interesting, yeah. Because now we the main thing we will speak about is not about material but different things. Yeah. So this is the model now. I hope you have the same one, yeah, because I sent you the email with this one. So now we have these bodies, and in this example, we will push the sphere in the block and deform the block, yeah. And we, because we are now in the space, the mesh will be a little bit greater. That means there is a large number of nodes, and because the displacements of nodes means the number of unknown values of the problem. So if we are in the space, the problem is bigger from the mathematical point of view, because there are many unknown values and the system of equation is greater. Yeah. So now we have this one. The material, I will apply the material to this block. Yeah. So I will add this my material to solids. And off, so add this one, apply. Okay, so I have now applied this material to this block. Yeah, that means in my model, this block will be deformable, and this bottom and top bodies, the blue one and the yellow one, and the plane and the sphere, will be undeformable. Yeah, this represents a ground, the blue one, and this is an indentor which will be pushed in the material. Yeah, but I think mostly you assume that the sphere should be pushed in the center of the block, not on such position. Yeah, but we can use boundary condition to describe so-called symmetry of the model. That means I will describe or prescribe such boundary conditions that this block represents only 1/4 of the whole model. Yeah, and this is useful because it's not necessary to solve. For example, if I watch it from the top. Yeah, so from the top. So if this block represents the right one represents only 1/4 of the model, then it's clear. Then the second quarter, this part, and the second half, this one, yeah, is deformed by the same way as this quarter. Yeah, so it's not necessary to solve the deformations, the stress on the rest of the model, because it's the same. Yeah, only symmetric. So it's very useful to use the symmetry and solve only a small part of the body. Yeah, because the rest is nothing interesting. There is nothing new for us, and we get only a greater model, a longer solution, but no new results. So I assume that this one is 1/4 of a greater model, yeah, and this is one plane of the symmetry, and this is the second plane of the symmetry. Yeah. So now I have to apply proper boundary conditions, and if you imagine that this plane is a plane of a symmetry of the model, and the model is symmetrical and symmetrically loaded and fixed, then the points on the symmetry plane before deformation or before loading should remain on the symmetry plane during the loading also. Yeah, they cannot leave the symmetry plane, because if they leave the symmetry plane, the symmetry is away. Yeah, that means all points which are on this plane should stay on this plane. That means the x displacement, the displacement in this direction, which is perpendicular to the plane, should be removed. So I can apply a boundary condition. The boundary condition is a fixed displacement. It will be a fixed displacement in the x direction, and it's applied to a solid face and to this solid face. So now I apply to this solid face a zero displacement and in x direction. Yeah, I can switch it on so it's visible now. And I can name it, for example, it's a symmetry in the plane yz, yeah, because this is the plane yz and the x displacement is removed or forbidden from this in this plane. Okay, so we have now the first symmetry boundary condition, yeah, and from this moment the behavior of this model is the same as behavior of one half of a model which has the second part here, which is not in our model. Yeah, and similar here, new fixed displacement, and now I have to bring to zero the z displacement, which is perpendicular to this plane. So z displacement 0, solid faces, this solid face. Yeah. It's called, for example, symmetric plane x, y, for example. Yeah. So now I have these two boundary conditions, you can see. So these two boundary conditions represent the symmetry of the body. Yeah. So from this moment, the behavior of this red body is the same as a behavior of 1/4 of a bigger body. Because the boundary conditions are applied to the body, not to a mesh, I can make the mesh just now or later. It's not important. I can make it in any moment, because if, for example, the blue one, the sim xy is applied to this plane, so all nodes which will be made on this plane later by producing the mesh, this boundary condition will be just applied on the proper nodes, of course. So now contact, where is contact? Here. And we have three contact bodies, yeah, the bottom, the block, and the top, for example. Yeah. So I will start with a meshed deformable. I will name it, for example, block. It will be solid body, the red one, yeah. This one. Yeah. So the red one, the block, is it's a contact body called block, and it's okay, it's red. Another contact body is the ground here, and this is geometric. Yeah, there will be no mesh because it's in this example it's just undeformable. So I can use this one, geometric, ground, and solid body. Oh, sheet body. Sorry, sheet body. In this case, because it's sheet body. And this one, yeah. So this is the one, the blue one. It's a sheet body. And third contact body is the sphere, yeah. Here it's also geometric. Geometric, for example, sphere, solid body. This one, okay, one solid body. Okay, so we have now contact bodies. One is meshed, deformable. You can see here in the tree view block, and two bodies are geometric, ground and the sphere. Okay, I can switch here the identification of the contact bodies. Yeah, here on the right side is just just display only. We can see block, ground, and sphere, red, blue, and yellow. If your model on the screen is not so beautiful, but it seems flat, and things like this, you can change it using this icon on the top. Yeah, it's just lighting. And here on the left from this is background. Yeah, so if you don't like the white background, you can change it to gray background, and of course you can change it to a general other. You can change everything you need, but I think this is so quite fast and simple to do, and sometimes it's useful for the presentation. This is of course much more better than this. Yeah, and another thing, this icon on the right side here, the surfaces are drawn as a set of small faces. You can see it's like these squares here. Yeah, and if you switch here this on, it's much more smoother. Yeah, it's again only a presentation. Yeah, but if you have, for example, not so good computer or not so good graphic card, this is better because it's not so expensive for the drawing, for the upgrading of the screen and so on. Yeah, but of course looks better. So this is only about presentation. Yeah, so now back to our model. Yeah. We have these contact bodies, and now we have to create our contact table. So new contact table. It's here. See table 1, okay. And there should be a contact between the block and the ground, and between the block and the sphere. Yeah, so block and ground, this is this position. Yeah, because you can see block is number 1 and ground is number 2, so it's here. And the main steps are still the same. Here in the contact it's quite long. Yeah, so I have to check active, contact interaction, create default, choose touching, create. Okay, I have new contact interaction touching between the body 1 and the body 2. Yeah, this is in fact a matrix, but it's a symmetrical matrix, so nothing more is important. Again, the second between the block and the sphere, this is this position, active, contact interaction, create default, touching, create. Okay, so now we have touching between block and ground and block and sphere, and okay, I can close it. Now what is the load? The load will be the displacement of this sphere. The sphere will be pushed in the block. So I can use a table again. So I will go to tables again, new one independent variable. The type of the independent variable is time. Now I have at points of 0, 0, it's the start, 0.5, 1, then the sphere is going back, and if we want to see a little bit more precise in the indent, so I can at a point, for example, 1, -1, that means the sphere is going away above the original position. I can use fit here to see the whole table now. Yeah. Okay.
Sorry, what's the last point did you enter?
It was 1 -1.
Oh, okay.
Yeah, because it means the sphere is going down and then it's going back, but it's going back more than to the original position, but it's going just more two times.
Okay.
Yeah. So, and now I can switch again to my model. So, for example, window, and you can see we have the table view and the model. Yeah, so I can switch now to the model. yeah, window, table, window, model, yeah. So if I work with the table there, it remains still this one. I can close it, of course, but why? So now I'm backing up in my model, and now I will apply the displacement of this body using the table. Yeah, so I'm going to the contact body sphere now, and I will change his position. That means control type is position, and his parameters. I have to find the window again here. So the parameters, yeah, there is 1 millimeter distance between these two bodies, yeah, now from the start, yeah, so I can move it, for example, 20 millimeters down. That means it's in the y direction, and it is against the direction that it's minus 20 times the table, yeah. So it's going by 20 millimeters down. That means 19 millimeters in the block, yeah, because there is 1 millimeter to the distance before, and then it's going to the original position and 20 millimeters back, yeah. That means the resulting position is 20 millimeters above the original position. Okay. So now the displacement of this body is defined, okay. So it seems everything is ready, but one thing is not ready, is the mesh, yeah. So now we can go back to the geometry and mesh, this first card here, and auto mesh volumes. And the only thing we need to create a mesh here is the red, is the block, yeah. So volumes, and choose target order linear now. Yeah, target order will be linear, and element size, we will use grade elements now, yeah. We know that this distance is 40, yeah, so I will use elements, for example, 8 millimeters grade, that mesh, this body, so this is my mesh now, yeah. So I use element size manual, not automatic, element size 8, tetrahedral elements, and I got such mesh. I think maybe an hexahedral elements maybe a little bit better, yeah. So I can clear mesh. Try this one. Target element size 8. Yeah, I think it seems a little bit more beautiful, yeah. So maybe this can be our mesh, yeah. So now we have the model with the material, boundary conditions, contact bodies, mesh. It seems everything is okay. So we can go to load case, new static load case. Loads the symmetrical boundary conditions, okay, they are, it's just only check, yeah, they are present, okay, but the contact is not switched on, yeah, we can see it's gray, the box here is gray. So contact, I have choose the contact table, okay, again, I have the contact table here, yeah, see table, if there's nothing here, there is no the contact switched on, yeah, so contact table, choose the one, okay. So now we have loads, contact, and it works, okay. And the last step in the model job, new structure job. And I have choose my load case. I think it's quite useful to switch stress on. Yeah, because by default, in the job results is not the stress. So I open the job results and check the stress as one of the results I'm interested in. Okay. And now I can use check here, and hopefully it will be okay. So check. And now we have a problem. Boundary condition, no geometric or mesh entities found. So we have anything wrong on boundary conditions. Okay, I will close it and go back to my boundary conditions. Boundary conditions. And now from my point of view, it seems okay. So I don't know what the problem. I can try to repair it. I will remove the item which is applied to. So now the boundary condition is not applied to nothing. It's applied to nothing. Yeah. I will switch the nodes on. You can see now the nodes. And I will change it and I will apply it just directly to the nodes. Yeah. So maybe this can help. So select selection control, method face fluid, nodes, and click on one node. And you can see the nodes are selected now, yeah, because they are face fluid, that means on this face. And these nodes are just selected, and I have to apply this boundary condition, add nodes. And which nodes? This one, the selected nodes, all selected. You can see this second possibility is all selected. Okay, so now the boundary conditions is applied to selected nodes. Okay, I can try now to check again, job, and check, and it's okay. One warning is away. Yeah, it's corrected. So this is good. So I can come back here, go to the second boundary condition. This one, remove all. Select selection control, clear this selection. Again, face fluid nodes. And I have these nodes, 66. And I have applied this displacement to nodes, add or selected. Okay. Okay, clear. Okay. So now the boundary conditions are applied directly to the nodes. Yeah? So job, load case, okay, check, it's okay. So run. This is the run job menu. I can use that. My computer has many threads, so I can switch multiple threads. I can give, for example, 60 now. But be careful with the number, because you can use all power of your computer for the solution, and so be careful with this number. Save, reset, submit, and hopefully we will get a result. So now it's running. And the time is going, yeah, 0.40, 45, 0.5, and so on. So we can see the solution is going. So I have to wait for the result. 304, perfect. And open post file. So the first just the animation. Okay, so it works, and I suppose. But it's clear that the result is not very good, because the elements are very great. Yeah, it means the results are not precise, because just the mesh is such great elements and only few nodes. Yeah, so for example, the deformed shape of this part is not very good, yeah, and I think we are interested mostly in this part, and so the result is not so perfect as I want. So now I have to close my post file.
Sorry,
Yeah.
I have a question. You know, I think I missed the first body, which is the sheet in the sheet body. I didn't fix it. I think you did it in the first, but I didn't notice that you fixed it by, I think, in X or in
No,
Y direction.
yeah, you mean the ground? Yeah, this one.
No, no, it's not that one. I think before, when you start to apply the boundary condition for the two faces, I
Yes.
think you applied a boundary condition for the sheet in the ground.
No. For the sheet in the ground, there is
Because mine, the cube is getting in the sheet and going down.
yes. So I think best thing we can do is if we have this problem, go to the contact menu, yeah,
Okay.
and check here identify back faces,
Yes.
and we can see that my contact body, the ground, yeah, has
Okay.
one face. It has this color. It's the bottom, and the
Okay.
second is the front. Yeah,
Yes.
is the same from you.
Mine is in the bottom and back outside. This is the
Maybe
first.
it can be switched there in your case. Yeah. So okay. Oh, I can switch this off. So yeah,
Okay, let me
this
switch
is
it.
top front. So
Okay.
if it's going through, there is a problem with the contact. Yeah. So maybe this is not the problem. Maybe it's a problem with the contact table. You have to have this touching here.
Yes, exactly.
Do you have?
Yes, I have it.
Yeah. You have both.
Yes, I have both.
Okay. And the mesh is similar, yeah, as my mesh, yeah, I suppose, yeah, your mesh.
My mesh is yeah, it's not triangle, it's not rectangle, but it's triangle.
Yeah, never mind. Yeah. So I really don't know where is the problem. Try
It's not okay. It's not. I can make this sheet in the cube like a good.
try this one, yeah. Try using flip sheet bodies. This one, yeah. We are in the contact still.
Okay, let me
There are
check
tools,
it.
flip sheet bodies. Okay, and choose this one.
Flip.
Now flipped. Now the front and back faces are flipped.
Okay.
Yeah,
So
and we can try it once more now. That means
okay.
save module. Yeah, so that means here at the top. Yeah, this is the
Yeah.
menu. Save, reset, submit, and we can try it once more.
Okay.
Maybe it will
I
be.
put it in run.
Yeah, and now you can see the same problem is now me
Yes. It's going through.
because I flipped it for I have.
Yes, exactly. That's what's happened with me.
Yeah, and that you it's okay now.
No, still going through.
So I have no idea now. Yeah, no idea what can be wrong. Maybe can there can be a problem when the block and the bottom before the start of the solution may intersect. Yeah, sometimes if they are intersection, yeah, then the contact cannot be established because there is no contact. There is the intersection from the start. But if you have the bodies with the same dimensions and the same coordinates as me, the problem shouldn't be there. Yeah. So I really don't know. Don't know. Yeah.
What of the coordinate system? Is it possible to affect it? Because sometimes someone's z, x, and y will be different from another person's.
Uh, just the orientation of the coordinate system can affect the results slightly, but this is, I think, quite a deep problem of problem of the theory of finite element method. But I think just such behavior as the contact, it should not depend on the orientation of the coordinate system. Yeah, this can be only there can be only numerical problems, but very small numerical problems. We can try one more thing. Close the
Okay.
post file. If the
Yes.
solution is still running, then kill it. Yeah, for my
Yeah,
solution.
yeah.
Yeah,
It's done.
is done. Okay. So sometimes can help if here in our model there is no free space between the ground and the block. Yeah, it's not free space, just in the zero plane. Yeah,
Yes.
we can start such that there can be a very small distance between the block and the ground. So we can move one of these two bodies, the block, for example, 0.1 millimeters to the top, or move the ground 0.1 millimeters to the
Okay.
top, for example. So I
Yes.
think the ground is just a simple geometric body, so it's better to move the simple thing. Yeah. So
Yes.
geometry and mesh, the first here.
Okay.
Here on the right, here we have move.
Yes.
Yeah, so move. And we have use a translation, and we
Yes.
will translate solids. So choose
Yes.
solids. The displacement will be in the y direction and to the bottom, that means minus
Yes.
0.1, for example, one solids. And now you have check. You just click here and with the
Yes, it's done.
So now, of course, on the model it's not visible yet, but we moved this body, so there is not an initial contact between the block and we can try it once more.
Okay.
I have to switch because I switched my button. So again, tools, flip. Okay. Save, reset, submit. And if that also this will not help, so I think the only thing is I will come to your office and we can speak about later.
Okay. Yeah.
Yeah, because I have in this moment no more idea what can we try, how to check.
You know, even exit a wrong message. It's
And
2004.
and which number?
2004.
Yeah, so you can now click on the
Let me flip my because I still
if you have an exit message, the flip if you only flip the body, there
yeah.
is just no contact, but not an error. Yeah, the contact
Okay.
is just not present, but it's not that it's the same as the body is not present. Yeah,
Okay.
if
Yeah.
an error exit message, there is another there can be another problem. Yeah, so we have to solve it separately later. Yeah, so
Okay. Okay. Okay.
because in this moment I have no more idea how to solve it. Yeah.
Okay. 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 No problem.
So now we have, if we succeed, we have this result. Okay, everything works fine, but not good for us. Yeah, because it's the mesh is not perfect here. Okay, so now I can change the model, and I can change the model so that I can use a different mesh with smaller elements. Yeah, if we have small elements, we can get a better result. Yeah, so I can try, for example, here in the geometry and mesh, and I can here use the subdivide menu, subdivide command. and I can divide all elements in the x, y, and z direction by 2, or by another number, of course, yeah, by 3, for example, yeah, 3, 3, and 3, yeah. Elements, and which elements? All existing. So now the mesh is much more finer, but also the number of nodes is much more greater. That means the problem is much more greater. Yeah. Okay, and I can try it once more. Save, reset, submit. And I have an exit message. There is a problem. Yeah, maybe the problem is like this one. Okay, I will explain it just a moment. Save, reset, submit. Yeah, now it works, but we can see that the solution is going much more slower, of course, because there is the model is much more bigger now, yeah, because there are many more nodes. Yes, so I will close. And now what I did to check the error message, yeah, I used this subdivide command. That means from each element in each direction in the x, y, and z, now 3 elements. That means there are many new elements and new nodes. Yeah, but this in general produced new nodes also at the positions of the original nodes. If you understand, there you have the original element was a block, and the new set of elements inside the block is 3 times 3. That means new 9 elements, yeah, inside each block, yeah. And on the corners of the original block there still remains the original nodes. It means on these positions are the original nodes and the new nodes, yeah. And so that means for example, at this position there is the original node and also the new nodes given by the new elements which are in this volume. Great. And using the sweep, you can see the help. Yeah, if they are duplicated geometric or mesh entities, the sweep will just remove the duplicities. Yeah, so using the subdivide, it's important to use the sweep then. Yeah. So now what about our solution? So we have only, you can see only 3% of the solution done. Yeah. Why? And because the model is huge now. Yeah, it's much more greater. I can open it and we can see in just a very small part of the result. Yeah. So at this moment I will kill the solution. Yeah, because it's clear I can get the result, of course, yeah, because you can see it's going on, yeah, the contact is going on, but I have to wait for a very long time now, yeah, and I am waiting for a long time because I have a very fine mesh in this part where the fine mesh is good for me, but I have also a very fine mesh in this part of the body where nothing interesting happens, yeah. So it's not useful to have such a fine mesh here. It's important to have fine mesh only here, where I just need it. Yeah. So I close my result file now. Go this menu, and I will kill the solution now because it will take a very long time and nothing interesting is coming for me. So kill. So now 3020 after user intervention. Okay, it's killed. Okay. So now I'll go back to my geometry and mesh. I will, for example, I will clear the mesh and I will create the mesh once more. So now I have the original mesh, yeah, the not so good mesh. And now I want to make the mesh finer only in a specific regions. So I can go to the card called mesh adaptivity here. Yeah, it's the 1, 2, 3, the fourth from the right side, yeah, the mesh adaptivity. And here is for us interesting the local adaptivity, this one. So I have to add a new item and I can start with the mean strain energy. I have to find the window again. Where is it? Here. So once more, mesh adaptivity, new, mesh adaptivity, new local adaptivity, not global, local, new mean strain energy. Yeah, and I have this window. Again, it has just a name, adapt1, okay. The type is mean strain energy. I can change the type to another one, but I just choose this one. So if the type, you have many possibilities, but I just choose mean strain energy. And now I have to read what is written here. The strain energy divided by mean strain energy is above, now is 0, that means it's nothing, then adapt the mesh. Yeah. So I can write, for example, 10 here. That means if in an element, his stride energy in the element divided by the mean strain energy of the whole body is 10. That means the strain energy in the element is 10 times greater than the mean strain energy of the whole body. Then I can adapt the element by one level. That means the element will be removed and will be replaced by small elements 1 times. Yeah. If there is, for example, number 2, the small elements can be in the next step replaced by much more small elements again. Yeah. So it's it's important to don't write a very great number here, because each level of the adaptivity means n times, if we are in 3D, 8 times greater number of elements of nodes in the domain. Yeah. So I will leave number 1 here, and this I can apply to add to all elements. Yeah. Okay. So now I define a mesh adaptivity. You can see here in the model's tree view is adapt1. That means if the strain energy in an element is great, the element will be adapted. Yeah. So now let's try reset, save, reset, submit. And what's the problem? The problem is that the boundary conditions are away. Yeah. Because I removed the mesh, and because the boundary condition was applied to the mesh, when I deleted the mesh, I removed my boundary conditions also. Yeah. So I think the best way is go once more to my mesh volumes, and I think it's much more better remove the mesh, clear the mesh again. And I will use tetrahedral elements, not hexahedral. The element size 8, linear, that mesh volume, yeah. Because if I use the tetrahedral elements, the boundary conditions applied to the geometry are valid for the mesh, yeah, also. Now the boundary conditions are still here, yeah. But when I remove the mesh, you can see they are applied to nothing, yeah, because the set of entities to which the boundary conditions was applied is removed, yeah. So the sim y set, it's a boundary condition which should be applied to the YZ plane, that is this one plane, yeah. So sim YZ, solid faces at this one, sim XY, solid faces at this Y. Okay. So now I apply the boundary conditions directly to the faces, to the solid faces, and using this mesh, they are hopefully applied to the nodes. Yeah. So load K, job 1, check. Our local adaptivity is applied to no elements. Yeah, because I applied the local adaptivity to the mesh, but then I go back to the mesh, remove it, and create new mesh. Yeah, so I have to go once more to the local adaptivity and apply. It's still defined. It's only the elements are not added. Yeah, so I have add all elements. Now it's applied to these elements. And so now job save, submit, and hopefully now it will works. Okay, it's working. Yeah, I can open the post file and watch to my result, and I can do it step by step. So 1, 2, and now we can see between the step 0.04, it's nothing. There is just a stress, yeah, the contact is there, but the strain energy is not great enough for adapt of the mesh. Now, here the strain energy is great enough to apply the adaptivity criterion. That means these nodes are now adapted. Yeah, and the next steps, the strain energy will be greater in other elements. That means the mesh here in this area where the strain energy is great will be adapted. Yeah, you can see still more and more elements are adapted. Yeah, so the solution is not done. Yeah, so we are not now at 40%. And now you can see how it works. Yeah. So now the mesh is now better. It's adapted, but it's adapted only in the parts of the model which are interesting for us. Yeah, where anything interesting is going on. Yeah, that means here in this part there is small strain energy, and so on. That means here is the mesh not adapted. Yeah, only in this part where the strain energy of the deformation is more than 10 times greater than the mean strain energy in the whole body, the mesh is adapted. Yeah, so I can close it. I can change the adapt criterion properties. Here is the number 10 means that the strain energy in the element should be 10 10 times greater than the mean strain energy, I can change it, for example, only 6 times and give 2 levels of adaptivity. Yeah. Okay. And I can try to save, reset, submit, and solve it once more. Yeah, and we can see here are elements which are adapted 1 times, and here are elements which are adapted 2 times. Yeah, and I think it's clear that the number of nodes is increasing very rapidly if you are not careful with the limits of the mesh adaptation. So, of course, in general, if you have infinitesimally small elements, the result is perfect. Yeah, but you can't solve such a problem because they have an infinitum of unknown values of and equations. So you have to find a compromise between the perfect mesh and a realistic mesh which works good enough for your purpose. Yeah. So I think the mesh adaptivity is a quite good thing. How to adapt? That means to increase the number of elements only in this part of the body, which it's where it is important. Yeah. So the solution is going on. Yeah, I think it's clear. We can see how it works. Yeah, so I think not so interesting. Result is as we assume. So okay, yeah, everything fine. Everything works. It's okay. Here is the stress, and here is nothing in the rest of the body. If you are solving such thing, yeah, it's going still. I will kill it. Yeah, okay. In the job menu, you can add more properties to the mesh adaptivity. And you can see you can put limits here, because the mesh adaptivity really can make in the model a very huge number of nodes or elements, and you can now limit these numbers. Yeah. So now, for example, in our model, we have a mesh composed from approximately 600 nodes and 2.5 thousand of elements. Yeah, and by the adaptivity of the mesh, these numbers are decreasing and the model is growing. Yeah, so I can add a limit. For example, now nodes are 600, so I can give a limit, for example, 2,500, yeah, 4 times of, I think, 10,000, yeah, 1,000, 10,000, yeah, I can 183, 184, 184, yeah, 10,000, yeah. And if the number of nodes in the process of adaptivity comes to the limit, I can stop the solution or I can proceed, but the adaptivity is stopped from this moment. Yeah, so I think if I need the mesh will be adapted and I come to results, so it cannot be adapted, so I can stop it. Yeah, if I suppose I will be succeed with the result also when the mesh is not more adapted, I can choose this one. Yeah, so in this case, I will choose proceed. Okay. Save, reset, submit. Open post file. And here we can see in the mesh 603 nodes and going to the next step, still 600 nodes. And in the next step, I'm still in the second step, yeah, because it's still, I think it's still solved. Yeah, and we can see in the step number 3, we have 1,300 nodes. In the next step, 1,600, 17, and so on. Yeah, so the number of the nodes is in each step greater because the mesh is still finer. Yeah, and if we come to 10,000 nodes here, maybe the limit is very weak, then the adaptivity will be stopped, but the solution will continue. Yeah, so we will see. So I think the limit was very weak. So we have now 4,000 nodes and we are in the time 0.42. That means in the time 0.5, the displacement of the sphere will be stopped and it will be taken back. So we can see that the limit was not taken in account now. Yeah, but I think it's clear what happens if the number of nodes will come to 10,000. Yeah, the adaptivity of the mesh will be stopped, and the rest of the solution will be made with the last adaptivity step of the mesh, and other adaptivity steps will be stopped. Yeah. So now we are in the 0.5 time. Now is the sphere going back just. So the result is, again, nothing interesting now. For us, it's important to understand what we did using the mesh adaptivity. So this is everything for our lesson for today, and it's also everything for this Marc course from me, because from next week I have another lessons, and I think you have enough information to study alone anything about Marc. If you have Marc installed, you have the help, and you have here 1, 2, 3, 4, 5 books, and each of this volume is a PDF file with few thousand pages. Yeah, and I think the best thing you can do is try the first, read the theory and user information. There are many very useful things. Yeah, and read demonstration problems. There are other useful things, and try just step by step the demonstration problems. Try to understand the theory and user informations. But of course, there are extremely many informations in these books. Yeah, so I think the best thing is every time try to imagine a problem you want to solve, and then just check which things from the volume A or volume E, which parts of these books are important for your problem. Yeah, so just read the book from the start to the end is, I think, not effective, but I think also not possible because of the number of the pages. Yeah, so try just imagine your own problems and solve your own simple problems and find the solution of your problems inside in these books, in the help. And the only thing is just working and sitting at the mark and trying this or this or this and trying to understand why it works, why it does not work, and so on and so on. So for me, it's all for today and all for this course. Thank you for your attention. And of course, I'm still here in the department. So if you want to discuss anything about and so on, so you can come and we can discuss about. So thank you and bye.
Thank you very much.
Okay, thank you very much.
Poprosím kolegy, počkejte tady chviličku ještě, až se kolegové odpojí a probereme ten rozvrh. Jo.
Dobře.
With respect to the link to the video. Thank you.
Tak já můžu přijít do češtiny, zaplať pánbu. Tak já už ten kurz Marku dál provozovat teda nebudu, ale navážu vlastně plynule těma výpočtovými metodama, které spolu máme. My to máme jako podle rozvrhu, to máme teda dneska v těch 10:40 a pak tam máme ještě nějaký blok ve čtvrtek, že jo, nějaký blok, jestli to chápu dobře. A to je jako dvoublok, jo, je to tak?
Je to tak, no.
Mám takhle dlouhý. Vyhovuje vám to ten rozvrh, nebo chcete udělat nějakou změnu, nebo něco, jak to vidíte, jo? V první řadě, chcete to takhle, nebo to budeme vymýšlet změnu? To je první otázka.
Moc mi to nevyhovuje. Já i v to úterý, i v ten čtvrtek to jsou jediný předměty, který mám, takže kdyby se to povedlo nějak spojit nebo přesunout k něčemu jinému.
Jasně, já vám určitě zkusím víc vstříc, ale já mám taky dost výuky, takže nějak jako sladit. A pak ještě mě by se jako fakt hodně hodila tabule, protože my budeme samozřejmě něco počítat, ale já prostě na vás musím nejprve naučit aspoň základy nějaký teorie, protože vůbec nevíte vlastně, co se počítá a proč se to dělá tak nebo onak. Jo? To je vlastně celá slabina toho kurzu, který jsem dělal doteďka, že vlastně tam úplně chybí ten základ, proč se to dělá zrovna takhle. Takže já budu muset jako najít nějaký způsob, nějakou prostě místnost, kde je tabule, kde budu moct prostě stát před tou kamerou a psát, jako jo, pak samozřejmě, jako už budeme počítat, je to jedno. Takže vy jste mi psala nějaký volný časy, kdy se vám to hodí na tenhle kurz. Platí to pořád, nebo mi třeba dáte nějaký ještě další nebo jiný časy, které bychom teda mohli využívat po zbytek toho semestru a já bych se zkusil teda do nich nějak trefit s těma místnostma a svýma časovými možnostma, nebo...
No já vám asi vám vykřížkuju rozvrh, tady mám jednu věc, která je tam narozvrhovaná, ale je to tam jenom formálně. To je v podstatě projekt, takže tak bych vám asi poslala rozvrh do mailu a to bude asi nejjednodušší, si myslím.
Dobře, pošlete mi rozvrh a já to zkusím já to nějak teda najdu a pošlu vám to a prostě si to takhle nějak dáme dokupy a začali bychom teda asi spíš až to příští týden, nebo uvidíme, jo, když to vyřešíme dneska, tak bychom mohli třeba začít už tenhle týden, ale spíš asi ten příští. Já se ještě o tu svoji část toho předmětu budu dělit ještě s panem kolegou Škodou, jo, který je nás na katedře taky. A my jsme se domluvili, že já bych mám v první řadě teda dal ten teoretický základ prostě, abyste věděla co a jak, a on by vám zase ukázal nějaký softwary ještě jiný, takže vy byste prostě pak měla být takový, že byste prostě tušila, jak se něco dělá v tom nebo onom a pak už byste se prostě v praxi pak rozhodla, že by se vám hodilo. A nevím, jak to bude teda s jeho rozvrhem, on ty výuky má mít, takže předpokládám, že on se pak přizpůsobí prostě tomu, co dáme dohromady dva spolu, anebo si ho budete muset domluvit zase nějaký jiný režim zase. Ale on to bude mít jednodušší, že on může sedět u počítače, protože to bude fungovat tak, jak tohle, že? A je možný, že se tam ještě, to se ještě domluvíme, že tam stejně zase šoupneme ty doktorandy, ty cizojazyční, tak to zase on možná bude mít anglicky, jo, ale to se uvidí ještě. Jo,
dobře.
Dobrý, takže já budu čekat, pošlete mi rozvrh a dáme to dokupy a začali bychom teda spíš týden. Jo,
dobře, děkuju.
jsme domluvený a prostě je to jasný. Bez vás děkuju, mějte hezky a zatím naschledanou.
Naschledanou.